All right, we're solving exponential and log equations now. So let's do these first of all. Actually, let me go back and find some of the ones that we started with. Yeah, solve. So let's see if we can sneak these in here. So this one says 3x to the third equals 9 to the x.
It's actually 3 to the power of x.
Oh man, okay. 3 to the power of x to the third equals 9 to the x. Is that it?
Yeah.
Okay. And that's different than this other one you have here, right? Mm-hmm. So that's this one right here. So here's the trick with this. Whenever you see a base, you see how 9 has a base 3? Yeah. Rewrite it in terms of base 3. So I'm going to rewrite it like this.
Would it be 3 to the power of 3?
It would be 3 squared.
Oh yeah.
To the x.
Yeah, I tend to I know it, but I accidentally write 3.
Yeah. Yeah. So I can actually fit this up here. So this is 3x to the third equals 9 to the x, which means 3 times x to the third equals 3 squared to the x, which means 3x to the third equals 3 to the 2x, right? Multiply them together, which means x to the third equals 2x. I'm just setting the exponents equal to each other. Make sense how I did that? And then now I can, well, first of all, you can see one of the solutions. Well, there's a couple ways to solve this. Let's just set it equal to 0, because if you don't, you're going to probably forget there's a solution of 0. Obviously 0 is one of your solutions, right? So this means if I factor an x out, I get x squared minus 2 equals 0. So either x equals 0, zero product property, x equals 0, or x squared minus 2 equals 0. Follow?
Yeah.
And if x squared minus 2 equals 0, what does x equal? Plus or minus the square root of 2. Mm-hmm. So there's your 3 answers. Good?
Yeah.
Questions about how I did that?
No.
Let's try this one. This just says 2 to the x times 8 to the negative x equals 4 to the x. So these are all base 2. If you ever see that they're all the same base, all of these bases have the same base. This is 2 squared, this is 2 cubed, and this is 2 to the first. So rewrite them all in terms of that base. 2 to the x times 2 cubed to the negative x, got it? Mm-hmm. Equals 2 squared to the x. Good? Mm-hmm. So this means I have 2 to the x times 2, remember I can multiply those to the negative 3x equals 2 to the 2x. What do I do with these exponents?
You add them.
Mm-hmm, good. So 2 to the x minus, adding is subtracting, right? You're really adding those together. Plus a negative 3x is minus 3x. Got it? Mm-hmm. Equals 2 to the 2x, which means 2 to the negative 2x equals 2 to the 2x, which means negative 2x equals 2x, just setting the exponents equal to each other. Which means negative 4x, just moving them all to the left, equals 0, which means x equals 0. Mm-hmm. One solution. Sometimes you have to think, did I clear a solution somewhere? Was there an extraneous solution? But I don't think there was. I think that's the right answer. Do you have the answer key to these by chance?
I think in the textbook, yeah.
Yeah, maybe look them up later. We'll see. Okay, this next one. This one right here. So this is e to the x squared equals e to the 3x times e to the negative 2. I'm just writing them both at the top. So let's do that same thing we did on that last problem. E to the x squared equals e to the 3x minus 2, right? Mm-hmm. Adding them together, which means x squared equals 3x minus 2. Mm-hmm. which means I have a quadratic equation. Let's solve it. Subtract 3x from both sides, add 2, factor x minus 2 and x minus 1, which means x equals -2. I'm sorry, not -2. X equals 2 or 1. And then it's always a good idea just to plug them in to make sure you did it right. So plugging this in here, plugging 2 in here gives you e to the 4th. Plugging 2 in here gives you e to the 6th divided by e squared, which is e to the 4th, and that checks out. Plugging 1 in here gives you e to the 1st. Plugging 1 in here gives you e to the 3rd over e to the 2nd, which is e to the 1st. That works. You could do the same with this. Plugging 0 in here. This is just going to be 1. This is going to be 1, and this is going to be 1. So definitely that works. And same with these. You can plug them in and check it out. Now, do you know how to use your calculator to plug in?
I think so. Like just to.
Do you know the awesome trick with your calculator? Shoot, do I have a calculator on here? Graphing calculator? Dang, I don't think I do. Too bad. There's a little trick you can use with the graphing calculator. A little trick you can use. And it has to do, you can watch it on my other videos, but I won't show it to you now, but it has to do with the store button on your TI 83 or 84. There's a store button. Yeah. I'm streaming live though, and I can't show it on mine without downloading it, but I'll do it another time. I'll do it for a different video, but I've done it in lots of videos. Let's do the next one. Let's skip that one because that's a domain. We're doing just solving. Actually, I'll do those. The domain of a function. How do you find the domain? Well, the domain for a log function, you cannot take the log of a negative of 0. It has to be a positive number. You can't take the log of 0 or of a negative number, which means whatever's inside the log has to be positive. So the domain, solve that equation, and that's going to be your domain.
Oh yeah.
So x over 3 is greater than 6, which means x has to be greater than 18. So your domain is from 18, not including 18, to infinity. Got it? Because if you plug 18 in, you'll get 6 minus 6, which is 0. And if you try to take the log of 0, it won't work. And the reason is because if you want to take the log base b of 0, that basically means b to what power equals 0. That's the definition of logarithm. B to what power equals 0, and that just doesn't have a solution. Make sense?
Yeah.
So it just doesn't work. So this one, the domain again, set that greater than that has to be greater than 0. So 1 has to be greater than x minus 1, which means x has to be less than 2, adding 1 to both sides, right? So x has to be less than 2, which means negative infinity to 2. Did I lose you on this? Are you able to see it? I'm wondering if you still seeing this on my screen? Okay, on the Zoom screen? Okay. Find the domain, range, and asymptotes and inverse. Oh, now they want to find all of those things. Okay. Well, again, the domain, set that has to be positive. So the domain is from -5, not including it, to infinity. Okay. The range, well, when you have a log function, it's the inverse of an exponential function. So your range is going to be all real numbers.
Yeah.
The range is not going to be limited. You understand that? So I don't have to show you. And find the inverse. Well, to find the inverse, remember you flip the x's and the y's. So this is your y, right, normally. So let's call that x equals ln of y plus 5. And now let's solve this. Well, to solve this, we're going to use the definition Remember, this means log base e, right, of y plus 5. So e, remember the equivalence, you take e to the x equals whatever's inside there. You remember doing that?
Yeah.
So e to the x equals y plus 5. And so then y equals e to the x minus 5. So that's your inverse. The inverse is e to the x minus 5. Got it? Find the domain, range, and asymptote and inverse. So same deal. The domain has to be 2x has to be greater than 0. So x has to be greater than 0. So the domain
0 infinity.
0 to infinity, not including 0. Good. Range,
Negative infinity.
good. All real numbers. And the inverse, x equals log base e of 2x plus 2. So subtract 2 from both sides. Do your little trick. E to the x minus 2 equals 2 times x. And then divide both sides by 2 or multiply. Whoops. What happened to my y? Yeah, sorry, I made a mistake there. This is y. My bad. That was being careless.
And then if you divide it by 2, then you get the y.
Yeah. Or multiply by 1/2 is a better way to think of it. So 1/2 times e to the x minus 2. So f inverse of x in this case is 1/2 of e to the x minus 2. Good?
So if you were to write it that way, would it be e over 2 to
It would be, and that would be fine to write too, but it looks a little bit better in my opinion to write 1/2 in front. But yeah, that's the same thing. E to the x minus 2 all over 2 is fine as well. Same deal. Good?
Yeah.
All right, same deal. I think we can do this. I'll let you do that one later. Same with that. I'll let you do those for practice. We already did that one. Let's see if we've got, all right, here we go, solve. Let's solve this equation. Well, whenever you take the natural log of e, that's basically log base e of e, which just cancels out. So it's just 15. That's it. You understand why?
Yeah. What is the point of like natural logs even existing if it's just e or log base e?
What's the point of a logarithm? What's the idea?
Natural log.
What's the point of natural log?
Yeah.
Well, the natural log is just the log base e. That's the point of it.
But won't people just write that instead of?
Oh, you mean why did they write ln
Yeah.
as a shortcut? Because it's such a, so the question is, why do they write ln instead of log base e? Because it's used so often. Exponentials in finance and like science, e is a very common e. It's the Euler constant. It's 2.7 something. That number, kind of like pi. This is such a practical number in the world. Just like pi is the ratio of circumference to diameter of every circle, which is like transcends thought, pun intended, because it's called a transcendental number. E is also a very, very crucial number because it has to do with like exponential growth and decay models. That number just happens to be a number. You'll see it later when you do some other stuff, but that number has a lot of application. So much so that the majority of the time that you're using logarithms, you're going to use log base e. That's why. So instead of writing log base e, they came up with their own little, almost like a shortcut for writing it, because it's literally the natural, that's what the n stands for, log. It's the natural log, but that's why. It's just the way it is. So how about this equation to solve this? E to the 5x equals 3. you're gonna take the natural log of both sides. See how much easier it is to just write ln instead of
Yeah.
log base e. When I take the natural log of both sides, this cancels, you get 5x equals the natural log of 3, which means x equals 1/5 times the natural log of 3. Done. Okay.
Or it could be like ln over ln